This is a News Channel 2 special presentation. Join our Storm Tracker 2 team for the Winter Outlook Show as they prepare you for the winter season ahead.
Welcome to the Storm Tracker 2 Winter Weather Outlook Show. I'm Chief Meteorologist Bill Cardis. You'll be joined by meteorologist Eric Gage and James DeFazio throughout the broadcast to get you prepared for the upcoming winter season. And of course, at the end of the show, we will be unveiling the outlook. Let's talk about snowfall here in central New York as we're gearing up for the winter season. I just wanted to spend a moment talking about what is a typical winter here and what does that look like? I know it's been a while since we've had a typical winter, but this is how it works. In November, we typically have about 8 inches of snow. Our snowiest month of the season is in January, but December, January, and February typically see over 20 inches of snow. The average snowfall over the past 30 years, 95 inches. Again, this is for the city of Utica. The average winter temperatures are typically below freezing. The coldest part of the year is in January. The average low is in the low teens, and usually the snow sticks around. Of course, we've had some very warm winters recently, but that's not typical. Some of the record years, take a look at this. The record snowfall, 185 inches, 1970 to 1971. The least snowiest season on record, 1923, 1924, only 26 inches of snow. We got pretty close to that during one of our record El Nino years in 2015 to 2016. The last 5 winters have been relatively quiet. It's been warm and snow has been way below average. In fact, last year we got less than 50 inches of snow. And we haven't had 100 inches since 2018 to 2019. Could this year be different? Well, stay tuned to find out. There are many different types of precipitation that we can see in the winter. Sleet and freezing rain are sometimes common, and we want to take a look at how these things form and why they're so different. What's the weather ingredients that make them? Well, first of all, in a situation where we have cold rain, temperatures at the surface are above freezing, and snow can fall through that warmer layer of air and melt. And in this scenario, this could also create elevated snowfall where the snow is falling and accumulating at a hilltop, but then as it moves into the valley, it warms up and it turns over to rain. In a special scenario, we can have a layer of warm air that's sandwiched between cool air. In other words, air that's below freezing. And so snow will fall into this warmer batch of air and snow will melt and turn over to rain. But that layer of cold air near the surface causes the rain to freeze on contact. We call this freezing rain. And in this scenario, it looks just like rain, except that rain is freezing on the surface. And that's very common here in certain weather scenarios that we'll talk about in a second. Another scenario which is very similar to sleet, freezing rain, is called sleet. The only difference here is that layer of cold air is thicker, closer to the surface. And so what happens is, as the rain falls to the ground, it freezes before it hits the ground, and it turns into frozen raindrops known as sleet. And of course, the last scenario here is that column of air is entirely below freezing, and that's what causes snow. So how does something like this happen? How do we get sleet and freezing rain in this complex environment? How do we get that warm wedge of air? It's most common with something called a warm front. So this is a 3-dimensional picture of an example of a warm front. And on the left-hand side, that's the warm air. On the right-hand side, the warm air is pushing into the cold air. And see this shallow slope that moves across your screen? That's kind of the dividing line of what a warm front does 3-dimensionally. And so that warm layer, as you get from the left-hand side to the right-hand side, it goes from warm to cold air. But notice the middle. That's where we find that scenario where we can have that cold air near the surface, and closer to the leading edge of that warm front, we find freezing rain. And then as we get more into the cold air, that cold layer gets thicker and thicker, and it allows for sleet to happen. And then, of course, we get to the right-hand side, that cold air is really thick, and we get snow. Warm fronts are very common. It's a very common weather pattern, and we think this winter we could have more of these scenarios compared to usual.
One of Central New York's most common winter phenomena is lake effect snow. Lake effect snow forms in a much different way than synoptic snow or snow from storm systems and low pressure centers. It begins with water within the Great Lakes that is very warm. We have cold air that gets brought in from the west-northwest, and as it moves over the lake, the warm water condenses and rises to form clouds. This graphic does a phenomenal image. It shows you the cold air being blown in from the west-northwest. It moves over the warm water of Lake Ontario. Those clouds form as the warm water rises and condenses, and as it interacts with the land and the topography, it even enhances convection and sometimes strengthens even further. Lake effect snow can be extremely problematic, especially for forecasters. At times, just a small change in wind direction can have an extreme change on the forecast. This is a look at different degrees that we use to forecast lake band orientation. A due west wind, we consider a 270-degree wind. This is all based on degrees of a compass. A 300-degree lake band orientation is favorable for Syracuse. For Utica, we're normally looking for around 290. But these are very, very subtle differences in wind direction, and they can make all the difference in the forecast. There is also another very, very, very problematic winter phenomena called snow squalls. Snow squalls can be embedded within lake effect snow, or they can be associated with just lake-enhanced snow. Snow squalls feature sudden onsets of snow, intense bursts of snow and wind, whiteout conditions, which tend to drop visibility to very poor conditions, and rapidly deteriorating road conditions. It is not fun to be driving during a snow squall. They do tend to be short duration. They can last anywhere from minutes to about an hour and a half. They typically are intermittent. However, they pack a punch very, very quickly. Lake effect snow overall is the majority of what we see in terms of our nickel and dime snow here in central New York. We do experience our largest snowfalls typically from the low pressures from the nor'easters or low pressure centers that track to our east. However, without the lake, we would not get nearly the amount of snow that we do.
In the winter season, we encounter a variety of different types of snow events or even snowstorms. And today we're going to talk about what each one means, especially when it comes to the most major of events, for example, clippers and nor'easters. To start, we'll talk about a clipper. If you hear this term a lot, it's because this is caused by systems coming in from the northwest, low pressure forming from Alberta, hence the name Alberta Clipper. And as it continues southward and eastward, it moves snow into our area. Now, the key with this type of system is it brings in a lot of cold air, and not just cooler than freezing air, much cooler air than 32 degrees, allowing lighter snow-type particles to fall. And when you come to an event, for example, which is the opposite, which is a nor'easter, that's when you get the denser snowfall. And these types of events start out with low pressure right along the coast of the Atlantic, and as you continue to see that low pressure move northward, it drags in that warm air inland and it encounters all that cool air in place here in our area. And when it does that, it produces heavier snowfall, and that's when you get temperatures near freezing and the snow being extremely dense that collects like cake on trees. Now, the path of this low pressure can always vary. Matter of fact, here's a look at two different types of nor'easters. They are called both Miller A and Miller B. Miller A is when you have a low pressure system out near the coast of, say, Georgia, South Carolina, Florida, and it continues northward, produces a decent amount of snowfall here in the central New York region, a wintry mix heading down to the city and some rain showers as you head south to, say, near Florida. Now, this band here could also shift eastward or westward, so we could sometimes see a wintry mix from the system. But you picture, for example, the snowstorm of '93 as a similar comparison to this type of setup. Now, there are other setups involving nor'easters. This is Miller B, which basically low pressure forms from right behind me out in the Midwest. It continues eastward, then it reaches the Atlantic as a separate low pressure, and then starts to shift north. The origin of the system is different, but the impacts are largely the same. As you can see here, snow in our area, wintry mix to the south, even some rain along the coast. And again, that could shift depending on the exact track of the system. You can picture the 2010 North American blizzard as an example, some pretty strong winds along with that. Now, what is the difference with the types of heavy snowfall? As you can see here, when you have clipper systems with temperatures, or I should say nor'easter systems with temperatures right around freezing, wet snow takes place where 5 inches of snow is equated to 1 inch of water. When you have, for example, a system from Alberta up in the northwest, you get snow which is a lot more dry, where you have 20 inches of snow for every 1 inch of water. So there are differences depending on origins of snow, and as we head into the winter season, we'll be sure to let you guys know where it's coming from and those impacts as we look ahead to any type of winter event. We'll be right back. Welcome back to our Winter Outlook show. Now, one of the things that is pretty confusing in wintertime are all the watches, warnings, advisories. What do they mean? Why do we have so many? Well, I'm here to explain exactly what each one means. So notice here we have a list of winter storm or winter weather watches, advisories, or warnings. The list from the top to bottom vary in intensification. Now, winter weather advisories are issued when we have generally light amounts of snow, blowing snow, ice that could impact travel, but it's not as significant as, say, a winter storm warning. Now, winter storm warnings are issued when we have confidence that is high that a system could produce significant impacts regarding snow, sleet, or ice. But notice here in the middle, this is a winter storm watch. This is issued well in advance of warnings to give you a heads up that we're tracking something that could impact us regarding, again, snow, sleet, freezing rain, or other significant impacts. And then as it gets closer and confidence is high enough, warnings are then issued. Note here the colors, purple indicating winter weather advisories, blue indicating winter storm watches, and pink indicating winter storm warnings. There are a few more winter warnings that are issued. First off, lake effect snow. This is caused by snow squalls originating from lakes, for example, Lake Ontario, Lake Erie, and these can cause rapidly reducing visibility. So just a heads up, when you see lake effect snow warnings on those maps, that you could go from seeing sunshine to near whiteout conditions in the matter of a few minutes, depending on where you're traveling. Same thing for snow squall warnings, except these are just not originating from lakes. Same type of effects right here, basically due to snow squalls. Blizzard warnings are not common in our area, but they are possible, and this is all due to widespread snowfall mixed in with wind speeds potentially higher than 35 miles per hour. And those colors here indicated right here, orange, bright orange being for blizzard warnings. Now, as we head into the middle of winter, usually when we see the coldest temperatures, there are cold weather advisories and extreme cold watches and warnings. Advisory issued when you have wind chills or temperatures below 15 degrees below zero or 20 degrees below zero in the North Country. A little colder of temperatures are required for extreme cold watches and warnings. Note here, 25 below or 30 below in the North Country. Same thing for warnings, except with watches, it's likely. With warnings, it's imminent, and it's likely to happen within the next few hours. Now, one thing you're probably missing here is that we are not receiving wind chill warnings anymore. This is being done by the Weather Service to basically remove any confusion regarding the wind chill watches and warnings. So again, this is a new thing that's being implemented this year. This is, of course, to simplify advisories for cold weather. So wind chill warnings are now being combined in cold weather warnings.
Winter weather preparedness is essential for a safe winter. We have several tips involving how to prepare your vehicle, as well as some driving tips on how to stay safe this winter. First, make sure that your tires have ample tread. Snow tires are great and all, however, without tread, you will slide no matter what. You need at least a half-inch of tread, and the old way of checking that can be done by just sticking Lincoln's head from the penny in between the slits of the tire, and that gives you a general idea of just how much tread you have. But you definitely need tread this time of year to make sure that you can stop in ample time on slushy and snowy roads. We also recommend checking your tire pressure this time of year. As it begins to get colder, the air within the tires condenses. Typically, you get low tire pressure this time of year. You may want to top off the tires at the beginning of winter. If not, when we do get to our coldest periods of the winter, your car very well may ask you to do so. We also recommend that you keep not just the snow brush and snow shovel in the car, snow brush and ice scraper in the car. I actually recommend keeping a shovel in the car as well, especially if you happen to park in a parking lot that might get plowed. Any large snowstorm could result in you being blocked in. Having the shovel is never a bad thing, and it can come in handy. As for driving tips, if you happen to skid and you happen to go into a slide, we recommend that you, as does AAA and local auto bodies, if you begin to slide, take your foot off of the pedal lightly, lift off of the accelerator or the brake, slowly steer into or towards the direction that you are sliding, and then begin to correct the slide before you put your foot back on the accelerator or the brake. That is easier said than done, but it will get easier with practice. And we do all of this because of these statistics. Each year it is insane how many people crash despite the fact that we know what is coming. More than 150,000 crashes occur each year due to icy and snowy roads. 135,000 of the 150 cause an injury, and 1,000 of them result in a fatality. So try to be as prepared as possible this winter season, and we hope that you stay safe and have a great winter.
Welcome back. It's the time you've been waiting for, the time to unveil our winter outlook. Our weather team's been working hard on this, and before I dive into the details, I want to mention this is a broad scale outlook. We aren't able to forecast specific parts of this. For example, the largest snowfall of the winter. Will we have a white Christmas? What's the coldest temperature going to be? Beyond our abilities. We could see these things about a week in advance. When we do an outlook, we're looking at the overall picture. How are things trending? Which is very different than trying to be specific here. We can use the Pacific Ocean to give us some clues as to how the winter is going to play out. This year, we are headed towards what's called La Nina. That's the phase of the Pacific Ocean that we're expecting. What does that mean locally? We'll talk about that. We're also going to look at some similar winters in the past and see how they played out with these conditions. All right, we're putting a chart on the map in front of you here, and what we're looking at is the Pacific Ocean and the phase of the Pacific Ocean. This is how things have been playing out over the past couple of decades. On the top, some notable strong El Nino years, 2015, 2016 specifically. That was a very warm winter with very little snow. We're not expecting that this year. Some La Nina years in the past, we've actually had a few of them in the recent past, but last year was an El Nino year, which also produced very little snowfall in central New York. We were under 50 inches. We're currently in neither phase. We're what's called neutral, so right in the middle. We think that this is going to become La Nina over the next couple of weeks. So what is La Nina? We go to the Pacific Ocean. Largest ocean on the planet, has the largest influence on weather. We find trade winds. These are winds that move from east to west. In La Nina, these winds are stronger than normal, and so what that does is it carries warm ocean water to the west, which is replaced by a pool of cold ocean temperatures. So this part of the Pacific, the eastern part of the Pacific, temperatures fall on the surface of the ocean. And this has consequences to the weather in North America. Cooler than normal ocean temperatures favors dry weather in the south, specifically Texas and Florida, and cooler weather in the northwest. Locally, this favors a western storm track. What does that mean? The jet stream carrying those areas of low pressure. There will be a few coastal storms that form over the winter time, but the track of these favors western runners, as they're called. We're expecting more mixed precipitation, more sleet, more freezing rain events in these weather patterns, and sometimes they can even bring rainfall, although it's less common. The challenge about this is that in a La Nina year, we also get a very active jet stream, which means we have a better than average chance of getting more winter storms, and they don't all go to the west. A few of these may end up going to our east, and we could have a couple of big snowstorms. Again, it all depends on the specifics here, but the odds favor a very active season, and the higher elevations in particular, especially north and west of Utica, might end up scoring big this year. We'll end up seeing how this plays out. Similar past years, we go to the 1980s. There were a few years that saw snowfall totals in the upper 80s to 90s. La Nina year in 1985 and 1986. The most recent one was 2013 to 2014 with 82 inches of snowfall. Remember, the average is 95 for Utica. The wild card behind all of this is the polar vortex. How does that play out? So far, it looks like the polar vortex will be staying pretty quiet, at least for the next couple of weeks. However, should that change, we could be getting into more active patterns here. You could see some of those cold snaps happen in January and February and March, and this could have a pretty significant influence on how the end of the winter ends up unfolding. And again, that's the wild card to the forecast. With that being said, this is what we're making the official call for our upcoming winter season. This is Utica specific, 70 to 90 inches of snowfall for the season, an average temperature of 27 degrees, which is above average in terms of temperature, below average in terms of snowfall, but not that below average. Last year we had 50 inches. Should we get 75 inches of snow, that would be 50% more than last year. We're thinking that it is going to be more of a winter than last year, but by the time we add up all the storms and all the snowfall, we might end up being just shy. What it looks like across the board, we wanted to do something a little bit different this year and expand it to more than just Utica. And take a look at this. These are some of the highlights in terms of the regional impact with a weak La Nina year and the overall scope. So 70 to 90 inches of snowfall for Utica that expands south and east into the southern valleys. We're expecting heavier snow north of the Mohawk Valley, 90 to 120 inches for the Adirondacks, and also for the higher elevations just south of the Mohawk Valley, the Tug Hill, and the western Adirondacks, some of those higher elevations, 120 to 150 inches of snow. While that is a lot more snow than the Mohawk Valley, it's still a little bit below average, even for those locations. But still, for snowmobilers, for skiers, we think this could be much more of an active season. And again, the other wild card here is the temperature, which again, a warmer than average winter, but I think less thaws than what we dealt with last year, and hopefully the snow stays on the ground a little bit longer than in seasons past. If you want this complete outlook, we're going to post the details of this on our website, WKTV.com. We thank you for joining us here this evening, and we will be continuing to follow the winter weather with you throughout the season.